Hello and welcome to Tableau Training Part 2. My name is Michelle and I'm with the Simplilearn team. Today we will be learning about the topics we discussed in Part 1, live versus extract data sources. We'll talk about joins and unions, and we'll look at table calculations. We'll look at the rank functions, and we'll look at actions, specifically URL actions. We'll talk about reference lines and bands. We'll look into some insights in the data, such as delay analysis. Also, we'll learn how to build a waterfall chart. And then finally, we will learn about level of detail calculations while making two different visualizations. In part 1 of this Tableau training, we introduced Tableau basics and we learned how to create donut charts and two-dimensional donut charts. And we learned about linking between dashboards. If you missed part 1, please check out the link in the description below. Now let's discuss the difference between a live connection and an extract connection. First, it's important to note that these different types of connections are not available in Tableau Public. It's always a live connection. And a live connection is where the data will update based on when the source of the data updates. So if you're connected to a database and something in the database changes, then you'll pick up those changes when you open the report, as it will query that database when the report is opened. Whereas an extract connection is extracted creates a subset of the data that improves performance. So when you're looking at it locally on your computer, you have an extract of that data set, that subset of the data, right on your computer or up in Tableau server, depending on where you're looking at it. And it does not update when the database updates. It only updates when your refresh updates it. So without a refresh set for that extract, you won't get the new data. As an example of this, let's say that in our sample superstore, we have Kelly Williams associated with the central region, but that's changed. So let's go ahead and change that. We will change it to Sarah Smith, and we'll save it. Now let's go back to our Tableau workbooks. And you can see, we can refresh it over here and see Sarah Smith come in. Over here in our extract, Sarah Smith doesn't come in. If we click to refresh the extract, it doesn't refresh the extract until we navigate to sheet 1. But when we go back to our data source, then we see Sarah Smith coming in. So that refresh can be scheduled, and it could run once a day or once every several hours. But you would need to set up a refresh or else you would never get Sarah Smith's data coming in. Next, let's talk about joining data in Tableau. So here we have the people table, but let's say we want to join it to our orders information. So I'm going to start with our orders table, and then we're going to pull on people, and Tableau is going to create a join for us, and it's going to choose the column that we would like to join on based on the names in the two data sources. So if these two data sources didn't have a column that had the same name, then Tableau wouldn't be able to guess what two to join on. So we would have to come in and select out of the orders side and the people side what we'd like to join on. And then we have the options to do an inner join, a left join, a right join, and a full outer join. Let's review quickly what these look like. So say we had two tables that we wanted to join together. One of them was the student table that had the student names and the key to their grade, and which we could use to look up their grade over here in the grade table, which had the key to their grade and the actual grade, A, B, C, D, F, and incomplete. We can see here that somebody has made a mistake and put in a letter grade instead of the key to the letter grade. And we'll see how that affects what we're looking at. So if we were to do an inner join, that would only take the rows where the join could complete. So we have 1 that could join to 1 just fine, but we don't have 2 and we don't have 3. A doesn't join to anything, so this row would be not included. And then 4, 5, and 6 would all join. So that would look something like this, where we would see Adam. When we grab student from this table and grade from this table, we can see Adam had an A, Beverly had an A, Dale had a D, Elizabeth had an F, and Frank is incomplete. And Charles is missing. Also, you don't see any B or C in this list of grades. For a left join, it's going to take everything from the left table and only the pieces from the right table that apply to the left table. So it looks pretty similar to our inner join, only Charles shows up. So the join wasn't able to complete since A doesn't exist in grade, but we include Charles anyways, and grade becomes null for Charles. It won't put in the grade key because we're not asking for the grade key, we're asking for grade from the grade table. So we try to look up A inside of the grade table, we can't find it, and it returns null. We look up A inside the grade key. Perfect. Right join is like a left join, only it takes everything from the right table instead of the left table. So it grabs all the grades, A, B, C, D, F, and incomplete, and only the rows from the left table that join appropriately. So since Charles doesn't join appropriately, he doesn't show up. We also have B and C showing up even though it doesn't exist in the student table, and it won't be tied to a student because that join wasn't able to complete as it didn't exist over there. And the last one is a full outer join, where it takes everything from both tables whether or not the join is complete. So we have all of the people where the join completes. We also have Charles where the join doesn't complete from the left to the right. And we have B and C where the join doesn't complete from the right to the left. So those are our options in Tableau. Here in our sample superstore data set, you could look and see if there are any regions in the orders table that don't exist in the people table. And that's how you can know what kind of join you want. And so if you want those orders to still show up even though they don't have a region, or their region is not in the people table, that's when you would do a left join. For our purposes, we'll do an inner join. Now let's say we had a second Excel sheet here that had more orders, and you can do a union, which is just adding more orders, by dragging that second orders table right underneath the original orders table. You can see it says there, drag table to union. And that's helpful for if you have an Excel sheet for maybe different years. So say you had a separate Excel sheet for the orders in 2015 and then another one for the orders in 2016. You could pull on your 2015 orders and then drag your 2016 orders right there to union, and it would take these orders and then add the rows instead of the columns for the 2016 orders. For example, we've added people but as a join, and that will first put in all of our orders as columns and then add the columns for our person. But if we were adding more data that fell under the order columns, so it would have the same data, the same order ID, ship date, but we wanted to add more rows, then that would be when you union. Now we're going to take a look at calculations and which ones are calculated on the database side versus which are calculated on the table side. So here we have percentage of total sales split up by subcategory and category. We also have percentage of total sales along table down. So the difference between these two things are one of them is made using a calculated field, which is where we do the sum of sales divided by the sum of fixed sum of sales. This part is called a level of detail calculation. And this calculation, the sum of sales and the sum of the level of detail of sales, which basically makes the database find the total sum of sales regardless of these dimensions we pulled on. So it gives us our total number. So this will be sum of sales for bookcases, and this will be sum of sales for everything. This calculation is done on the database side, whereas this one, percentage of total sales along table down, is what's called a table calculation. It's a quick table calculation of percent of total, and it is done in Tableau. It's processed locally right inside of the table after the aggregations have occurred. There are some pros and cons of doing it this way. So for this percent of total sales, I had to create the table calculation here, and it does the fixed sum of sales where it finds the sum of sales for the entire database, and since it is fixed, it will ignore filters. So for example, I took off both of the sales and I'm just going to put on the percent sum of sales, and let's say we wanted to see how office supplies and technology are as percentages of sum of sales and ignore furniture. So we can grab category and we'll control click and drag, and we're going to unselect furniture and hit OK. Now it's still taking it out of the total sum of sales including furniture, and so our grand total down here is only 67% instead of 100%. Whereas if we take sales and double click it and it adds it over here on the table, then we right click and do a quick table calculation and click percent of total. This one is doing it out of 100 and these numbers don't match. And that's because it does take into account the filter of category. So let's pull the filter of category off, and we can see that they're both out of 100% now, and each of these take into account the same amount of data since we have no filters here. So if you wanted to take into account the filters on the table, then you need to use a table calculation. However, when you push the information back to the database to do the calculation, it's doing it as part of the query to the data source, and it can save you some time. And so which one of these is faster sort of depends on what data is available already when the original query comes back. Next, we're going to discuss ranking in Tableau. First, let's add a second data source. So we can do that by coming up to Data and clicking New Data Source. Or you can just click this plus data source right here and click Microsoft Excel. We're going to use this rank example worksheet. Perfect, and it's already pulled in the sheet we want because there's only one sheet. And we'll go to sheet 2, pull on store, pull on sales, and we will rename sheet 2 as rank example. Great, so now we have, here's all of our stores and here are our sales, and if we wanted to rank them based on who had the highest sales to the lowest sales, we could create a calculated field called rank by sales. And we're going to use our rank function and we're going to put in sales. Now we receive this error here, so when we hover, we see what that arrow says. Oh, you can click. And it says all fields must be aggregate or constant when using table calculation functions or fields from multiple data sources. So we learn something unique here that you might not know, is that a rank is a table calculation and it requires it to be aggregated. So we can make sum and put the parentheses around sales and our error goes away. So now we know rank is a table calculation. And we have our box here that expands out and can teach us about what we're using here. So when I click on rank, it will tell us that it returns the standard competition rank for the current row, and it says identical values are assigned an identical rank. So let's see what that looks like. We'll hit OK. We'll double click on rank by sales, and we can see our ranks. So E had the highest sales, so it's 1. D is next, and C and B are tied, 20 and 20. And so they both share the rank of 3, and then because they are 2 of them that share the same rank, we skip 4, and the next one gets 5th place. But now this isn't the only way to rank, so let's make another one of these. We'll click duplicate and edit. Let's erase copy, and we're going to call this rank dense by sales. Double click on rank, start typing rank again, and we're going to click rank dense. Now the difference here is that rank dense returns the rank where identical values are assigned an identical rank but no gaps are inserted in the numbers. So we'll click OK, double click rank dense, and you can see instead of going 1, 2, 3, 5, it goes 1, 2, 3, 4. So it doesn't include that gap. Now, let's give them a little bit more space here. And maybe I want it to be in the order I created it. So these measure values are defining what's going to happen up here. So we can take sales and put it at the top. And that'll move sales to the front. And put rank dense at the bottom. So now we can see sales. We can see rank by sales. Rank dense by sales. Now let's duplicate. And look at the next one. We have rank modified next, and change the name here. You notice that I receive an error, and that's because that name already exists. Tableau won't allow you to use the same name, and it will give you that error. So those errors can be pretty helpful in finding out what's going on. Hit apply and OK, and then double click rank modified by sales. And now we can see the difference here. Let's go back here and look at what it says here. Click on rank modified, and it says it returns the modified competition rank, where identical values are assigned an identical rank. But what happens instead is, instead of both receiving 3 for third place, they both receive 4, which is the lower of the options. So if we were going by rank and we just arbitrarily decided that this one's third place and this one's fourth place, then they both receive the same rank here, but they receive the higher of the 2 options, whereas this one receives the lower of the 2 options. And let's do one more. Duplicate, edit, erase copy, and we're going to do rank unique, and let's change the name to rank unique. Perfect. And now this is going to give it a unique ranking even when they share the same number. So we'll hit apply, OK, double click rank unique, and we have 1, 2, 3, 4, and 5. So what it's doing is, let's quickly look here. So rank by sales. We haven't talked about this yet, but you can choose to rank it ascending or descending. That means that, do we want to rank it based on whether, you see here it says ascending or descending, and that's how you'll define. So it defaults to descending, and it's saying the biggest is the best. So for sales, that's accurate. So what it's doing is biggest down. Now here it has to decide which one to give 3 and which one to do 4, and it's doing that based on the ASCII values of the store. So it's looking at more information on the row. And since uppercase B comes before lowercase c, uppercase B is getting the 3, even though they both have 20 for sales. Let's go back now to our orders data, and we'll make a new sheet. And now we're going to talk about actions in Tableau. We've talked about actions briefly before in our Tableau training video for beginners. So if you want to see the introduction, you can go and look there. Also, if you want to follow along with our data sets, you can comment below and ask, and the Simplilearn team will get you that data set. So let's make a chart where we're going to look at category. So we'll drag category onto columns, and then we're going to look at sales. So we'll drag sales onto rows, and it will create 3 bar charts for us. And we're going to call this sales by category. Now let's make a second chart that we will use together, and we'll bring category onto columns, and we'll bring subcategory onto columns. And let's bring sales onto rows again. And let's take subcategory and bring it onto color, and that makes each subcategory its own color. And we'll call this sheet sales by subcategory. So now back to sales by category. Here you can make a worksheet action where we're going to move from the sales by category sheet to the sales by subcategory sheet and also filter down that sheet to only the category we want to see. So click filter, and we can name this filter go to subcategory. And we're going to do this filter on select. So this name won't be seen except for in our actions list. And what sheets do we want to affect? We're going to have sales by category show up. One thing to note here, it is only showing the sheets for it to affect based on the ones that are using this data source at this point. So you can see we have 4 sheets down here, but it's only showing 3 sheets, and that's because rank example, if you recall, is using the rank example data source. So you can click here and you can see all the sheets, or you can see the other data source. If we click rank example, it will show the rank example data source. So we just want sales by category to be the source sheet, and the target sheet, we want it to be sales by subcategory. So on select, we want it to be sales by subcategory. We're going to use all the fields available to create this filter and hit OK. So now we have our go to subcategory on select. We'll hit OK again, and let's make this a little wider so we can see. And so when we click on furniture, it will take us to only furniture of the sales by subcategory. We go back to category and click on office supplies. Now we just see office supplies. And this is a way to make Tableau drill to a lower level. Great. So we have those. Now let's duplicate this sales by category sheet. And let's see, if we go to worksheet and we go to actions, you can see that we have the action here go to subcategory that still exists on our duplicated sheet as well. So you can see it's affecting both sheets, sales by category and sales by category too. Let's say we don't want that, and we can unselect sales by category too. And hit OK, and hit OK. Now when we go to worksheet actions, you can tell that it's not affecting that sheet. So if we come and click technology, nothing should happen. But we go to sales by category and click technology, it'll take you to the technology subcategory. Great. So we have our sales by category 2. Let's bring it to the end. Rename it. We're going to call it sales by category stacked, because we're going to take subcategory here and drag it onto color. And now we can see our different subcategories in the colors there. Now we can take a look here and sort by subcategory based on sum of sales. And now you can see that it is the biggest sales at the bottom for each subcategory. That's just a way that I like to view it. So let's do a highlight action, and we're going to do it on a dashboard. So let's take sales by subcategory and look at it over top of, or sales by category stacked over top of sales by subcategory. So we want both of those. Let's make our dashboard automatic for testing purposes, and we'll go to dashboard, we'll click create actions. So we're going to add an action. It's going to be a highlight action. Highlight sales by subcategory. And we are going to have the sales by category stacked be the source sheet, and the sales by subcategory be the target sheet for all fields. Okay, okay. And on select, you can highlight your chart there and see where it falls inside of the other visualization. A cool thing you can do is you could select office supplies here and it will highlight all of office supplies, or if you drag and select a couple of them, it will show you those. So you're just like, I want to see all these small ones, or I want to see this one and these small ones, or whatever. Then it will highlight the ones that you drag and select. Now this is also true of our sales by subcategory and sales by category. So when we clicked on technology, it filtered to just technology. And we'll undo that. And when we drag and click office supplies and technology, we get office supplies and technology. Now if we go back to the dashboard, we can see that this dashboard is now filtered also to office supplies and technology, and that's because we're using the same sheet. And when you navigate away from that sheet, it doesn't mean that your filter goes away. So when I clicked undo, that's when it caused the filter to go away. So if you're going to have two things affect that sheet, just remember that just because you navigated away from what you selected doesn't mean that what you selected goes away. That filter will stay there. And it shows up right here. And if we pull it off, everything goes back to normal. However, the action is still there. So when you click on it, it comes back. Now let's take a look at the last kind of action, which is a URL action. So we're going to make a map based on state. So I'm going to double click state, and it's going to build out my map. Let's change it to a filled map by clicking map up here. And we're going to take sales and put it onto color. So now it's colored based on the darkest is the highest sales. We're going to put state onto label, so you can see the state name, and we're going to put sales onto label, so we can see the sales amount. Let's quickly change our default property for sales, so that it always shows up as currency. And we're going to lose the decimal places, so it'll, by default, show up with a dollar sign, and so on. Great, so now we have our sales map, and we're going to create a worksheet action. Now the difference between a worksheet action and a dashboard action is that a worksheet will only affect the worksheet and a dashboard will only affect the dashboard. And so when we created our worksheet action on sales by category, if we were to pull sales by category onto the dashboard, that action won't transfer over. You'll need to make a dashboard action. So we're going to make a go to URL action. We're going to have it on menu. We're going to call it wiki. And it's going to only affect our new sheet, sheet 6, which we should rename. And we're going to have a URL in here, so this will take us to Wikipedia, and then whatever you put at the end of the Wikipedia link, it will take you to that page on Wikipedia. So we're going to take state and add it to the end of that link. And now to test the link, you can just click test link, and it will take a random value and show you what it will look like. So now that's how we know that we have our link set up. Okay, click OK. Let's rename our sheet to URL filter by state. And so when we click on Texas, okay, back to URL filter by state. Let's go to our worksheets and go to our actions, and on the go to subcategory, it is also affecting this URL filter by state because we didn't unselect it. Now, to keep that from being a problem, we're going to just come here and sales by category be the only sheet, and that way it won't auto-select new sheets as you create them. So, we'll no longer have that problem. You click on Texas and nothing happens except for it highlights that one only. That's how it should be. But when we hover on Texas and wait long enough, oh yeah, on click, sometimes you just have to hold still. It'll come up with our little link here, and we click on wiki, and it will open up our browser with the Wikipedia page for Texas. This can become really handy in the event that you have data that maybe has an order ID, and you can take that order ID and insert it into a URL in your system so that it can take you to your web interface page for that order. Here it's helpful for if we wanted to learn more about the state of California, which it can have information about the languages spoken and population, which can be helpful when we're looking into our sales information. Another way this can be useful is by showing the web page right inside of Tableau. So let's make a dashboard. Change our size to automatic, and let's pull in URL filter by state. If we go to dashboard actions, you can see there are no actions for this dashboard yet, so we're going to add a go to URL action on select. And since it's on select, the name of this URL won't show up, but it will show up in our list here, so it's nice to name it something unique. Let's put in our Wikipedia page, and it'll take us to state. So we'll hit OK, OK, and now when we click on Oklahoma, it'll open up a page for Oklahoma. But let's unselect Oklahoma. If we drag on web page from the objects here, You don't even have to enter anything for your URL. You just hit OK. And now we have the bottom half of the screen is a web page, and when we click on Oklahoma, instead of taking us to Oklahoma in a separate thing, it'll take us to Oklahoma right here in the visualization. So we'll change it to Texas, and this will change to Texas. If you unselect, it leaves the page there based on the one that you had just selected. Next, we're going to take a look at reference bands and lines. So let's make a new sheet, and we're going to call it reference lines. And so a reference line is found on the analytics pane, and it is something that comes and draws a line on your visualization based on the data on the screen. So let's make our visualization. We'll do our category and subcategory again, and we'll double click on sales, and it brings it onto text. So that's not what I want. So let's do sales onto rows, and we have our bar charts. And we'll talk about the difference between a cell, a pane, and the table. So when we go to analytics and we go to drag our reference line onto our visualization, it says you can add the reference line for the whole table, for a pane, or for a cell. So if we take our subcategory and drag it onto color, since the subcategory is our lowest level, it's going to define our cell. So each one of these, if we drag our reference line onto cell, each one of them gets a reference line. You see how it added those on? This is our dialog box. We will look at that in just a moment. So let's remove that. If we take reference line and put it onto pane, that's going to be similar to having category onto color. So each of these different colors is now a pane. Reference line onto pane, and you see how we get reference lines based on each pane. So let's undo that. And now if we take category off and everything is all one color, and we take reference line and put it onto table, now we have our reference line for the whole table. Great, so we're going to find out the average for each section. So I'm going to take category and put it back onto color, and we'll take reference line and put it onto pane. Now we have our reference line. It's based on the computation of average, and it's using the value of sum of sales. So since it says sum of sales here, you might think that it is taking the reference line and putting it at the sum of the sales, but that's not what's happening. It's just using our aggregated version of sales to figure out the average. So instead of taking each individual sale that makes up the bookcase section, it's taking the sum of sales for the bookcase section and comparing it to the sum of sales for chairs. So it's taking an average across these added up sections. We could also have it be total, where it's adding all of these up and it makes that total line. The sum line is the same as total in this case. A constant, which is where you get to define the value, and so if we wanted it to be 200,000, there it is. Let's go back. There we are, back to where we were. Constant, minimum, which shows you the minimum for each section, the maximum for each section, or the average, or the median. So let's stick with average, and now you can see it's labeling the line as average. We could also have it label the line as the value, so now we can see that the average is this amount of dollars. Or you can choose custom, and then you can put something in here. Like maybe we wanted the computation, a colon, and then the value, average, this amount. You can also have show recalculated line for highlighted or selected data points. That means when you click on a section, it will recalculate the average just for what you've selected. We'll hit OK. And so in that case, when we click on tables, you can see our recalculated average line. So the average for tables, for just tables, is the sum divided by the number. So the sum of tables is 206,966 divided by 1 is still 206,966. So selecting just tables isn't really helpful. But if we wanted to know the average of tables, and we'll control click appliances, and we'll control click binders. Oh, there we go. all three of those are selected, and we can see the average of those three, which is this line. You could also select like this and see your new average. Oh, and it's doing the average independently. So, select these guys, and now we see the average of just those 5 categories. And those are reference lines. Now, let's duplicate this sheet, and I'll show you how to delete a reference line. So, we'll rename this to reference bands. Click on this reference line, right-click, and click remove, and it takes it off. We have the same thing for reference bands as we had with reference lines, where you can have it be for the whole table, per pane, or per cell. So let's do a reference band for the whole table. So it's doing entire table, and it's taking from the minimum to the maximum. Now we could change the minimum to be the average to the maximum, and now that will highlight the whole table. Everything that's above the average becomes highlighted. And if you wanted to change it, you could do the minimum to the average. But let's go to average to maximum. And then you can change things like you can add lines. So we have a line for the average or the maximum. You can make it thinner, you can make it dotted. You can change your fill, so maybe if you don't want it to be quite that dark, you can change it to be a little bit of a lighter color of gray. And you can have show recalculated band for highlighted, or you can remove that, and that way when we highlight stuff, everything just stays where it belongs for the entire table. And that's how you create a reference band. Reference bands and reference lines can be really handy in making several different kinds of visualizations, such as bullet charts. If you have any questions about that, please comment below and the Simplilearn team will get back to you. Now let's do another analysis on average days to ship. And for this one, we're going to look at it by state, and we're going to look at it by ship mode. And so we'll take average days to ship and put it on columns. And now we can see the average days to ship by first class, same day, second class, or standard class. And you can see how they differ. So let's change the order of these really quick. If we come up here to ship mode and we click sort, and we click manual, we can have same day above first class, so that it kind of goes in order of priority. So same day, first class, second class, standard class. There we go. And now we have it in order of what you might expect and priority. And now we're going to create a calculated field that we will use to do a sort of conditional formatting. And we will name it delay analysis. Great. So let's do if the average days to ship is less than or equal to 2, then we'll have it return the words shipment early. So if we want to press enter there, that won't cause any problems to our calculation. So you can press enter, you could have extra spaces, and it won't, Tableau will ignore those. So this allows us to format our calculated field in a way that's easy to read. So if it's less than 2, then they're going to call it an early shipment. Else if average days to ship is greater than or equal to 5, then shipment late. And else if, let's get the rest of them. And average days to ship is not less than 2. Greater than 2 and less than 5, then on time. 2 words. On time. And now you can see we have an error here. It says expected end to match if, and that means that we don't have an end at the end of our if statement. If statements always have to have an end. Okay, let's hit apply. And let's grab our delay analysis and put it onto color. And it has on time as blue, early shipment as orange, and shipment late as red. We can double click on the color and we can change shipment early to green. And now we can see the best ones, the on time ones, and the ones that stand out as late. And standard class happens late a lot. It's interesting to see that on average, the District of Columbia has second class as a late shipment. You can see that all of these share the same axis size, so they all go from 0 to 6, even though this one never gets that close to 6. If we click Edit Axis, you can choose if you want that to be the case. So it's like right now, all of them use uniform axis range for all rows and columns, and that's really nice because it's easy to compare Colorado to Colorado to Colorado. If you change it to independent axis for each rows, you can see now this one only goes from 0 to not even 1, whereas this one goes from 0 to 6. And you can compare it with color, but you can no longer compare it with size across all of these different categories. So uniform axis range is the default in this case, and we will keep it that way. So now we have a quick analysis of our delays. We're now going to build a waterfall chart based on profit. So we'll call this our profit waterfall. And we'll take a look at what a waterfall looks like at the end and talk about how it works. So after we build it, we'll talk about some of the benefits of having a waterfall chart. So what we're going to do is build it over time. For this visualization, we're just going to look at the year of 2014. So I'm going to filter it to the order dates for 2014. And then we're going to take our order date and bring it onto columns, and we're going to look at it by month, but we're going to look at it by our discrete month. So you can see that I chose the one that has month and year, and then I chose discrete. And then we're going to take profit and put it onto rows, and we're going to change it from profit to our running total of profit. So you can see that it takes January and then it adds February to it. And so it's always getting bigger when we undid it. Sometimes there's up and down. So back to, we have our running total where it will sum January and February for the February mark, and then sum January, February, and March for the March mark. If I take profit and put it here, you can see January is negative 3,000 and February is positive 2,000. But here, it's the sum of those, which is negative 467. Take that back off. We're going to change our marks to a Gantt bar. And now we're going to duplicate profit and edit what we have. We're going to call this negative profit. And it's going to be just profit with the negative sign in front. Oh, it looks like I've done this before. So now we have a new name because I added a space at the end. So hit apply. And let's delete the old one. Okay, so now we have our negative profit. Just to look at it, it's just minus profit. And we're going to use that to determine the size of the Gantt bar. So what it does is it takes where the line was and it adds the size of it to be the size of profit. But because the line was at the top and we didn't want to build the profit up, we had to change it to negative profit, so it would build it down. So here, the line was down here because it was so low negative, and we added negative profit. And then let's take profit and put it on color. And so you can see where profit is negative, it turns it orange. And where profit is positive, it turns it blue. So what's happening here? What we can do now is we can see our total sales at the end and how we got there. So for the first month, we were at 0 when we started and we went down to negative 3,000. The next month, we were at negative 3,000 when we started and it grew up to be almost back to 0. And then we can see that from there on out, we grew up each month, and you can see how much each month contributed. Our biggest contributors are November and March, November being a little bit bigger. And you can see where we started at the beginning of that month and where we ended. And that's how a waterfall chart works. So it lets you go through over time and see exactly where our problems were and exactly which months helped the most, where we started and where we ended for each month. Next, we're going to talk about level of detail calculation, and we'll talk about those first by showing an example. So I'm going to bring all my customers on by name, and then I'm going to bring on order ID, and it's going to add all members, but then I'm going to change order ID from a dimension to a measure, and we have a count distinct. So now we can see each customer and how many orders they have. So let's sort it, and we can see one person has 17 orders, and we have 1, 2, 3, 4, 5, 6, 7 people have 13 orders, and it goes on from there. So what if we wanted to make a visualization that would show how many customers had how many orders and what number of orders was the most popular? We would need to do a level of detail calculation. So let's clear the workbook. A level of detail calculation allows you to build a visualization and bring on metrics that are at a level that is different from what's shown on the visualization. So, in order to do this, we need to create a calculated field that will show us the number of orders per customer, even though we're not going to have our visualization be per customer. So let's call this orders per customer. And we'll come here, and we're going to use a level of detail calculation called fixed. Now there are two other level of detail calculations, and they are called include and exclude. And you can learn more about those in some of our Simplilearn classes, and if you have any questions, please comment below and we can answer them. So we're going to do it fixed, and you can choose dimensions, and it computes an aggregation using only the specified dimensions. So it will ignore all the other dimensions, and we're going to have it based on customer name. So we're going to have fixed customer name, and we're going to get a count distinct of order ID. And make sure you close it with your curly bracket, and we have no errors, and we'll hit OK. And this allows us to see number of orders per customer, so let's pull it out. First, let's make it a dimension, and then pull it out onto our columns. And now we can see 1, 2, 3, 4, 5, 6, 7, 8, up to 17. So that means we had some customers just order 1 and some customers order 17, and we had them order everything in between. So if we'd never had a customer that had 9 orders, then 9 wouldn't appear in this list. Now we're going to take customer ID or name. Let's do ID because it should be unique. And we'll pull it onto rows, and we're going to change it to a measure, and it's going to be a count distinct. And so now we can see how many customers ordered how many items. So we have our number of orders per customer, which is at the per customer level, even though this visualization is not at the per customer level. There's nowhere in this visualization where we pull on a customer item as a dimension. So let's sort it, biggest to smallest, and we can see that 134 of our customers ordered 5 items, or had 5 orders. And so it just 5 is the most popular, 7 is the next most popular, 17 is the least popular, 1 is relatively unpopular, which is interesting to know. And so you can use this to analyze how many items your customers generally order, and maybe if they have 4 items that they are going to order, that perhaps if you made good suggestions you could get them to go up to 5. And that's an introduction to level of detail. So let's name this sheet Level of Detail, LOD, orders per customer. Perfect. Now let's make a new sheet, and we are going to do an analysis about new customers. So we'll call this Level of Detail, New Customer Analysis. So this visualization is going to be about customer acquisition over time. So when we do things over time, we grab our date and pull it up here, And for a line chart or anything over time, we're going to use these so that it makes an axis instead of just change to line, instead of dimensions or something that is not continuous. And then we're going to take our customer ID, pull it onto rows, but let's change it to count distinct customer ID, and now we can see our count of customers on every day. I think day is too low of a level. Let's go at month. So now we can see how many customers made an order during what month. Let's take region and split it out by region. When we click on central, we can see central. Now this is including all customers, but say we only wanted to include a customer when they're making their very first order. So we're only going to include their first order. So we need to create a calculated field, and we want to compare, we'll call it new or existing, and we want to compare their order date per customer to their first order date, the min order date. Nope, order date. And we're going to get this error. It says cannot mix aggregate, which is min, and non-aggregate functions. And what it's saying here is that this order date is at a per row level since we don't have any aggregation on it, and this order date is at a per visualization level, so it's only going to split up based on the visualization, and it won't let you put those two things together. So we're going to use our level of detail calculation again, and we're going to make this fixed per customer ID, and then we'll do our min order date. So now, instead of trying to return something different based on the visualization, it will always return the min for each customer ID. So if the order date on the visualization is equal to this order date, if the order date on the visualization is equal to the first order date for that customer, then new, else existing, end. So when the order date equals the very first order date, that means that it's a new customer making their first order. Otherwise, it's an existing customer because it's no longer their earliest date. Apply. Okay. And now we can take our new field, which is new or existing, drag it onto filters, and we only want new. We'll hit apply, and we can see that we have new customers, but less over time. So now we're going to change this count distinct to be a running total, and we can see over time how our new customers are adding up. So it's taking the prior value and adding our new customers, and then at the end we get our total customers for each region. And we can now make this a the lowest level, which is day, and you can see places where it like levels out. So we can see we have a lot of new customers and it's increasing, but then here for the region of East, there kind of is a level spot where we're not getting new orders. And that seems to be the same for each of them. So for February of 2014, why were we not getting any new orders? And how come the West region is getting new customers? How come the West region is getting new customers faster? Here, while it's leveling out in the red, it looks like the West region leveled out as well, but picked up sooner and started getting new customers. So this type of analysis will help you view new customers over time. And it's only possible because we were able to do a level of detail calculation here on new or existing that would compare this data at only aggregating the data for the specified dimension. So we were able to grab their minimum order date here. So those are a couple of ways that level of detail calculations can be very helpful. In summary, today we learned about live versus extract Tableau data sources. We learned about joins and unions in the data sources. We also looked at table versus database calculations. We looked at how the different ranks compare. We built some actions into our dashboards, filter actions and highlighting actions. We also looked at URL actions. We built dashboards that used reference lines and ones that used reference bands. We did analyzing of average days to ship and delay analysis. We built a waterfall chart, and we also looked into some level of detail calculations. Thank you for joining us today. For any questions, please visit www.simplilearn.com or post any questions below on the video. Thank you and have a great day.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.